Hello, good day to you, sir, and to my classmates. We are the Group H, and we will present and explain the electric field problem Sir J gave us. So the problem is, a particular of charge 1 is located on the x-axis at x equals 6.4 centimeters, a second of charge at x equals 4.3 centimeters, and the third charge is placed at x equals 5.0 centimeters. Find the electric field strength at the origin. So the next reporter will be Mr. Rebello. He will determine the given and also will convert the distance to centimeters to meters.
So the given of the problem, the first charge is 8 microcoulomb and its distance is 6.4 centimeters. The second charge is negative 8.02 microcoulomb and the distance is 0.43 centimeters. The third charge is 2.78 microcoulomb and the distance is 5.0 centimeters. To find the electric field, we will use the formula. The formula is electric field equal Coulomb constant multiplied by charge over distance squared. As you can see, the distance is in centimeters. So we need to convert it to meters because the unit of measurement of distance is in meters. To convert it, divide 100 to the centimeters. To continue this, Mr. CQ will be the next reporter and will explain what will be the direction of each charges.
The point or test charge is located at the origin. So the direction of the point charge to E1 is to the right because the positive test charge will attract to negative charge. Because if a positive test charge is attracted by a negative charge, so direction is toward to the charge. The direction of both E2 and E3 is to the left. The positive test charge will repel to a positive charge, so direction extends away from it. As you can see, the charge is in microcoulomb. We need to convert it to coulomb, so the conversion of negative 8.02 microcoulomb will be negative 8.02 times 10 raised to negative 6 coulomb, while the coulomb of 2.78 microcoulomb will be 2.78 times 10 raised to negative 6, and the 8 microcoulomb will be 8 times 10 raised to negative 6. To get the value of E1, Mr. Acido will be next reporter to continue.
So, to get the electric field of E1, we need to use the formula. The Coulomb's constant is 9 times 10 raised to 9. The charge is negative 8.02 times 10 raised to negative 6, while the distance is 0.043. So, to get the answer, E is equal to 9 times 10 raised to 9 times negative 8.02 times 10 raised to negative 6 over 0.043 squared is equal to negative 390,37317.47 Newton per Coulomb. But we need to write it into a scientific notation watt. So it is negative 3.9 times 10 raised to 7. Also, to get the electric field of E sub 2, we will use the formula again. E equals to 9 times 10 raised to 9 times 2.78 times 10 raised to negative 6 over 0.05 squared is equal to 1000800 Newton per Coulomb. In scientific notation is 1.0 times 10 raised to 7. To get the electric E sub 3, Mr. Tagibaw will continue it.
So to get the answer for the electric field of E sub 3, we need to use the formula again. E is equal to KQ over R raised to 2. After that, input the given. E is equals to 9 times 10 raised to 9 times 8 times 10 raised to negative 6 over 0.64 squared, and the answer will be 17,578,125 Newton per Coulomb, and its scientific notation is 1.76 times 10 raised to 7. To continue and to get the final answer, Mr. Supan will be the next reporter.
So to get the final answer, we need to add all the value of these three. The value of electric field of E1 will be positive because the direction of it is to the right, while the value of electric field of E2 and E3 will be both negative because their direction is to the left. So 3.9 times 10 raised to 7 plus negative 1.0 times 10 raised to 7 plus negative 1.76 times 10 raised to 7 is equal to 1.14 times 10 raised to 7 Newton per coulomb, and the direction of it is to the right.